Please tweet everything, CSNYC. Yes.
This is Kelly. She is the fastest tweeter of anyone I've ever met. I think she has a special software designed to tweet as fast as you can. Welcome, everybody. It's so good to see you all. This is such a cool space to be in. I'm so glad you could join us. My name is Eric Allatta. I'm a high school computer science teacher at the Academy for Software Engineering. We want to give you guys an opportunity to look at how computer science can look in an untraditional environment. Computer science links up with so many concepts that you might teach in your English classroom, your mathematics classroom, your science classroom. We want to make sure that we can see what it looks like in all those different environments. But I'm really excited to introduce some of our presenters today. Our first, Ashok, is going to show us scalable game design. So without further ado, thank you so much for listening. Ashok, lead the way.
All right. My name is Ashok Basawapatna, and I'm from the University of Colorado, and we have this program out there called Scalable Game Design, and right now we're trying to bring it to New York City. And so we're having a professional development in August. If you like what you see, please contact Cindy Gao and sign up for it. And it's all free, and it should be exciting, and it's in 3 days in August. So the idea behind scalable game design is low threshold, high ceiling tools. So low threshold means that students can create games very quickly and easily with no prior programming experience. But high ceiling means not only can they create these initial games very quickly, but they can actually eventually build up and do complex science simulations or complex AI patterns, for example. And our big idea is that computational thinking is not just a computer science thing. It should be in every classroom. So a lot of times we have computational thinking just in a computer club, for example. But really, why can't it be in the life science classroom as well as the math classroom? So far, our project has been funded by the NSF, and it works. Over 15,000 students have participated across the United States. Over 20,000 games and simulations have been created by these students in a variety of areas, including Native American reservations. It has shown to be effective with minorities and women and second language learners, and it's sustainable. Teachers choose to stick with our curriculum even past when they need to. It's one of the largest NSF CSN scale-ups in the country. So here's a little video.
I'm looking at the step right here. So that line segments, you can just move guys around.
Well, actually,
But on rays, this is ray that starts at this point, goes to B and keeps going. Even if you got a 4, and even if you got a main square, you'll have an in left.
the point of the game is to make the other guy run into like pit or make him fall into the pits. Point of this game.
We were just so impressed. We're like, wow, we get to make Pac-Man, we get to make Frogger, and I made a Space Invaders game, and then we get to create our own games, and it was just so much fun. And then we're like, okay, now we got to try to teach these kids, and everybody that was there weren't really elementary teachers. They were kind of like middle school and high school teachers, and they were teaching computer science and math, and we said, oh, we're going to try with our 4th graders, and everybody's like, whoa, I don't know about that, but these guys blew us away. They were doing more in a half a day than it took us than we did in like 3 days. You know, I was like, holy cow, these guys are amazing.
There are some problems.
Typically, kids would just look it up on the Wikipedia, but instead, the computational thinking approach is to say, let's look at this idea and express it computationally. So for instance, mods can be conceptualized as bits and pieces of mods, so you can stack them up. But then you can say a simple rule for mod would be if this is a piece of mod, and if there's nothing below it, then it falls down, right? And so that would be a rule. You say, if I'm a piece of mod, and if there's nothing below me, I drop down. And then you take this idea, you express it computationally as a rule, like if there's nothing below me, I drop down. And then you apply it to many, many agents, like thousands of agents. And then the computer essentially takes your idea, visualizes the consequences of your own thinking, and shows you the result. And so you reconceptualize this idea, and you get a sense of how it really could work by expressing these rules and having the computer help you to really understand how science works.
What?
have a 4.
You have to do the order of operations. You have to do, you know, you have to kind of have some common sense, you know, like, well, I shouldn't have, like, cars filling up the whole road or else it's impossible, you know? So you have to do some common sense and, you know.
Does that make sense now?
Got associated.
So that's just 4 moves instead of having to do it like this. So apply, okay. Reset it and play. See what happens. Oh, now you're in trouble. Now they're chasing you. They're coming after you, man. Look out!
I just don't know how to do Game Master.
With what?
I don't know my Game Master anymore. Game Master.
I think this definitely helps them think and problem solve, because it's, you know, well, it's got to be sequential and logical, and it's got to, if there's a problem here, it's got to be something that we did here, so they can figure that out. You know, the computer doesn't make the mistake; it's what we put into it. So I think they're starting to figure that out.
It takes, you know, you have to have, it's not like a one-day project, oh, I can just do this in an hour, you know? You have to put some thought into it and really.
All the ghosts are Super Pac-Man with hammers.
I've designed 2 so far. Well, actually, I tried making 3, and just kind of started my 3rd one.
So it's this whole negative backlash that, you know, when we ask kids and say, what do you think about programming at the middle school level? They say, oh, programming, that's hard and boring. And that's not a trade-off. It's not that they say, oh, it's hard, but if I do it, it's going to be very fulfilling. It's just, from their point of view, hard and boring. So it's a kind of skill that really doesn't get much of their attention, and ultimately they don't really care about any kind of computing related careers, and consequently, you know, we have a hard time to create the next generation of our 21st century workforce.
And we say, what's these ones right here? Boom, 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 boom. So I go delete, and then it's just 1, 2, 3.
My favorite part of class is just designing games. That's what I want. That's what I've always wanted to do when I grow up.
Yeah?
Mhm.
Why?
Because just computers are so interesting. They're so amazing. Sometimes I think, you know, sometimes I'm playing video games and I'm thinking, now how would they design that? I'm thinking things like that sometimes.
So that's a quick video on the Scalable Game Design project in general. Let's not start it again. We have this path from games to simulations. And these are a few examples. The same kind of interactions you use to create the game on the left there is the same kind of interaction you would use in the simulation. So this is a ghost tracking Pac-Man. You might have a predator tracking a prey, for example. So as kids are learning how to create their games, they're learning the tools necessary to create simulations. And I'm not going to go over these too in depth. I'm going to show a few sample games now. So here's a low threshold game that a student made. And it actually looks fairly complex. It's called Sakuban. And some of you might have seen this game before. But this is a first-person version of Sakuban someone made in Agent Cubes. And it's this game where it's a puzzle game where you push these boxes over these targets. But he made it in first-person view. And if you leap over these targets, it zooms out. So you can actually see the whole puzzle and actually try to push these boxes over. So you have to leap out, memorize the sequence of moves, and then figure out how to get these boxes over those targets. And these are kids making these games. Similarly, we have this high ceiling. So that's this low threshold. Pretty quickly, you can make a complete game. But we have this high ceiling of AI patterns that you can actually integrate into your game. So this is called collaborative diffusion. Pac-Man is diffusing out a scent, and the ghosts are tracking Pac-Man. And since they block Pac-Man's scent, they're actually splitting up, collaboratively trying to get Pac-Man. And this is a similar thing. This diffusing of scents and hill climbing is a similar thing that goes into making the Sims game. So this is a Sims game that we do with some of our college students. And this person made a South Park Sims game, and it uses Maslow's hierarchy. So up here at the top, we have 3 different needs. He has a food need, a friend need, and an entertainment need. And depending on which need he has, he tracks to that item in the house. So if he needs to talk to friends, he goes over to the friends, and the friends are emitting a friend center. If he needs to look at the TV, he goes over to the TV. And if he needs to eat pizza, he goes over to the pizza. And so there's this high ceiling, meaning you can make these complex games fairly quickly after you learn the initial rules. And the final thing I'll show you is this transfer from games to simulations. So this is a Frogger game up top, and this is an epidemiology simulation at the bottom. And basically what happens in the Frogger game is if the frog jumps in front of a truck, he changes into a dead frog. And similarly, in the epidemiology simulation, if I'm a healthy adult and I'm next to a sick adult, I change into a sick adult with some % chance. And that would be the % chance that I have of contracting the disease, for example. And so you could also think of death rates. If I'm sick, then I erase myself, and that would be a death rate for the given disease. And so you can see how games start to transfer to simulations. And that's what we're trying to teach. We're not only motivating through game design, but we're trying to integrate computational thinking concepts into the classroom environment. If you're interested at all in any of this, please contact Cindy Gao. She's going to be doing professional development with Alexander Repenning, the guy in the video, here in August. And yeah, with that, I'm open to any and all questions. I guess we don't ask questions, right? We just hand it off.
Thank you, Ashok. Could we take a few questions or maybe clarifying questions?
Yeah.
That, John sets up his level?
Yeah. Go for it.
Have you had any success with students that we rate 1s and 2s, meaning that they're at the lower third of their performance?
I have anecdotal evidence, so I don't know if we have any actual formal studies, but I do have anecdotal evidence for multiple teachers saying, these students were my worst class, and they were my best class when we did scalable game design. They were so focused, and maybe it's partly because it's something that they're motivated to do because it's game design and they're interested in, and maybe it's also partly because it's something that people can grasp intuitively more easily. But I don't know of any formal evidence to that effect.
So there's been a lot of work out in Berkeley with Marcia Lynn. She's shown that students manipulating simulations really helps increase their science output and knowledge. She has not done the transfers from the game design to science knowledge, but I think a big part of scalable game design is to motivate the patterns and the concepts early on with the game making. And then the next project is a simulation that uses those game making skills in a science context. So they get that extra step in the way to help them, so you're not just telling them how to put something together, you're actually building it themselves. And that aligns really well with the new National Science Framework, computational thinking standard, right? How to think about the interaction behavior of objects, the collection of data, all of these things that are these new strands that people are still figuring out what they mean. This is an excellent example of what they're doing.
Yes.
So what's available today either from you or other resources in terms of curricular elements that you could drop into a class that would integrate some of those?
So are you thinking of simulations or game design?
Yes.
Okay, so both. I mean, there's a lot. So we have a scalable game design. The short answer is we have a scalable game design wiki that has a lot of tutorials for simulations and games. But we have stuff like Frogger, Sokoban Sims, Space Invaders, for games, maze craze games, and then for simulations, we've done everything from like forest fires, epidemiology, predator prey, natural selection, the mudslide simulation Alex was talking about. So there's a huge variety of stuff, and then if you come to the PD and say what you specifically want to get out of it, we could maybe help you with that too.
One of our hopes as we began doing these meetups was to just to be a space where an already existing community could come for an evening, and that community would start to just step up and say, I've got something I really want to show everybody. Can I have that time? Which is exactly what John did. He has some awesome things that his kids have been doing that he really wanted to show this group, which is exactly what we were hoping would start to happen. So, John, thanks so much for bringing this and brought somebody with you.
Thanks. So I'm John Martin. This is Jessy Joe Gomez. And so I taught a game design curriculum last year at an unscreened high school in Canarsie, and it was to all the freshmen and all the sophomores. So pretty much what I wanted to show is just some tools, some things we did. This is before I knew about Bootstrap or I knew about agent sheets, which are awesome, and I did the training for those, and those are amazing. So when I was teaching, I recruited Jessy and some other teachers, especially when the kids were doing individual projects, because just to be able to give them like personalized instruction. And this is a video Jessy made just from some of the students she's working with.
I really like Scratch. It's very, very, very cool because you get to create your own video games, and I've never done that before. I like trying new stuff.
You get to be creative, and you can draw things like that you can control, and it's just a good way how to make a game.
I am on Scratch and I'm playing other people's games. I like to see what they do and I can learn from them.
Code, you just have boxes basically that have words in them saying what it will do and what it can do. And by putting certain things in them, it'll do certain things when playing a game.
So Jessy made that, and then recently at the school she's at, the principal liked it so much
that they're going to show it at like an assembly. They put it in like the kind of school's newspaper, and they're really excited about it. So they want the parents to really understand what they're doing. And I mean, of course, I asked parents permission before getting their voices, and I just thought of a creative way of kind of sharing students' work is to use their voices and not use their faces, but use more of their images. And if you can remember from before, they're like kind of talking heads. So those are actually each of the students' own avatar that they've created, and I just kind of created a talking mouth in front of their games and in front of their code. That was a lot of fun.
So we went through Scratch last year, and then we progressed to using a free platform, at least for the first 100 events. This is like an event-driven thing called Construct, and it has a physics engine built in. So after we had kids, some of the more ambitious kids making their own physics, we showed them this that was already built in, and this is one made by a student named Austin. So one of the things that's kind of cool is that this is a plug-in to Construct called Clay, and it lets you do leaderboards. And one thing we found was that when kids start to be able to track their high scores, and I know they have persistent variables in Scratch now if you have an older account, but it was just cool. It added a whole new level when kids can play and compete and stuff like that. So this was Austin's game. And his title screen I thought was pretty interesting. So he was a sophomore. He was somewhere on the Asperger spectrum. And he just came up with this on his own. And basically, I asked him how he came up with the concept. So basically, the narration was like, you're red, I'm blue. I know I'm breaking the fourth wall by sort of telling you that, the narrators try to implement their destruction. I was like, where'd you come up with that? And he's like, oh, yeah, it's just the concept of the omniscient narrator. And I was like, wow, Austin, that's... So it was cool. But this is just, some of the things. And it works well with this kind of retro style gaming look. But it has... physics and stuff built in, and so you can apply like sine functions to make the trees go back and forth, and do cool things like shake it. And it's pretty hard, so he said he wanted to make it like a rogue game that is like unforgiving, so you just die and that's it. which is part of the success, I guess, of like Flappy Bird, because you just get addicted and keep trying it. But he was pretty happy with that. And it was cool too, because kids knew he was very smart, but then this added a whole new level of respect when he made it, and they're like, wow, this guy's awesome at game making. This is just some trials, like using the physics stuff, just an art experiment, and they did the art using a free program called Sumo Paint. So, just sort of for like an aesthetic experiment. And this is another one by Andreen. So, this was another one that in the kind of the first class, kids can modify, some of the popular games, which, back then it was a little bit Angry Bird. So he modified this and came up with a concept where, basically you just have to, his new rule was just to try to get the pigs like out of the area there, and you get like 3 tries to do it. But it is cool in terms of like, content across district. The physics properties in there are pretty intense. There's like impulse, force, friction, angular friction, rotational friction. So they do get exposed to a lot of, physics just through that. This one is something cool with Construct that I thought might be cool. This is online multiplayer that you can do. And let me see if I already have it up here. Okay, I can kind of just show you this as an example. So one thing that you can do with Construct is you can do this online multiplayer. So I was thinking if anybody's interested, sort of collaborating, kids could make games at different high schools and sort of play each other online, and we could have like a tournament or something. So this comes with the new free version that you download, and it's got a template in there to do sort of the multiplayer stuff. So somebody else logged on, okay.
You can log on with your phone.
Yeah, it's a cool thing. Like with Agent Sheets, it's HTML5 and JavaScript, so you could do it in a Chrome browser on your phone, so kids could actually play each other on their phone. And this was kids doing like a multiplayer test. And one other thing I thought was cool is with multiplayer, okay, so basically that game was like a online multiplayer, a cooperative game where one person, it was a platformer, but one person would shoot and like destroy bricks, and the other person would make them. So they had to work together. Sometimes someone had to shoot it for you, so you could jump on top like a ladder, and then sometimes you had to clear blocks out of the way. So I think that, that's really fun. And then this was a cooperative, like local multiplayer where they just play on the keyboard. And we found these games where kids had to work together or play each other ended up being like really popular. And, just in terms of the title screen, a lot of kids are more into the storyline, less into just like gaming. It kind of opened them up.
Yeah, so a really great thing that we find about game design is that not only is it about coding or creating the mechanics of the game, which are obviously amazing to learn, you can work on your writing skills because you can be a storyteller in game design. You can work on your math skills, especially when there's physics involved. And you can always work on your artistic skills if you're more interested in sprite editing or just creating the art for the game. So a lot of kids usually find something that they like about it, which makes it also really great for collaboration.
So this is a game where they have to shoot fire and ice, and the storylines, when they do it, makes a block, and they have to keep doing that in sync to keep climbing and climbing. Even just like Pong, like I do this with my advisory group, and I don't know, you guys have seen Pong before, but they modified it basically to be the Pong paddles can go back and forth, and they can go sideways, and it's 6 players, and it gets like really chaotic and really fun having 6 people move their paddles all around. And should probably wrap up. So then I can, if anybody's interested, these are just some other sort of like resources. There's a bunch of games now where kids have to code to play the game. So 2 of them are Code Combat and Beta the Game. And you have to do something like JavaScript. Another one's an app where you can just program in there. And then these are just some of the technologies. We use Construct. Unfortunately, it only runs on Windows, but Stencil is pretty similar. These are all HTML5 platforms. And if they want to move on to pure JavaScript, there's some JavaScript game-making libraries. And then we found too, just with Scratch, it is kind of fun when you use controllers with it and kids can start playing. So if you have a Mac, this was Joystick Mapper, and you just basically map the controls to keyboard things. So that adds like another layer of fun for them to control their Scratch games. Thank you.
Can you make that presentation public and post a link to it on the Meetup page?
Yeah.
Would that be great? Okay.
Yeah.
Then everybody can get a link to those great resources. That's awesome. Can we take a couple maybe quick clarifying questions? And then we're definitely going to open it up after our last speaker as we switch out computers. Got a question right here.
Oh, sorry.
What kind of specifications did you give when you were creating games? Could they do whatever they wanted, or did it have to have elements of...
We started off with sort of giving them templates that they just modified. So we'd give them a Pong template and say, change the paddle, change the speed, and then...
Like for final projects, they get more freedom based on what they've learned throughout the semester.
And I'll post too, we did do a link to try to help them think through all the components of a game. Like we listed a whole bunch of different mechanics they could do, because like the shooter thing is one of the least actually popular across the spectrum. So it was more, I don't know, sharing, matching, building, puzzle-based, platforming.
What about like physics, math, storytelling?
Yeah, I mean the storytelling. So when they sort of got their concept, we did try to refer them to if it's something with a combat thing, why don't you use parts from the history sort of that you're using, make it real characters, and that'll make it more engaging. But that was kind of the hook, is like how do you make a better game? It's not let's force the content in there. It's like this will make a better game. Like use historical figures.
What's next for this group of kids?
Well, the long-term thing was, and originally I got into it because I taught all seniors, and it was kind of a thing to give them marketable skills. So I think that one of the end goals is to have them take the Microsoft JavaScript, HTML, CSS certification, and have that as sort of some marketable to put on their resume. So we go Scratch, Construct, and then JavaScript, and then some HTML to have like a portfolio to post their games.
We weren't sure if we'd be able to, that Lev would be able to get here, but he's here. He's going to give us a very quick, I know you guys have been sitting for a long time. Lev's going to give us a very quick overview of another curriculum for blending computer science in a humanities classroom. Thank you, Lev.
Okay. Get this up here. Okay, so hi everybody, my name's Lev. I'm a New York City school teacher, or I've been a New York City school teacher up until very recently. Well, I want to say thanks to CSNYC for putting on this wonderful event, the Flatiron School for the Space, of course, and especially for including StoryCode, computer programming through literature, which is an idea sort of more off the track than we usually see. This is computing, what's computing across disciplines, okay? And we've seen computing in algebra, and we've seen computing in game design. Right, okay. In both cases, taking the form of or using video game design as a lens. Okay, absolutely wonderful stuff. I'm so eager to incorporate it into the work I do. Not everybody, lots of people do, but not everybody gets excited about video games, okay? It's certainly something that needs to be in curriculum all over the place, but let's compute across disciplines. Let's go a little further across disciplines, okay? So what does StoryCode do? Well, people have been telling stories to each other for hundreds of thousands of years. We've been writing them for thousands of years, okay? It's no accident. This is how we engage each other. This is how we entertain each other. This is how we stimulate each other. There's no reason why you can't use that automatic human engagement that we have to model principles that work in computer programming or, in fact, in almost any STEM area. I just finished up a 1-hour webinar on using fiction to teach STEM. Where's my cursor? All right, so what StoryCode is, let me make this bigger, okay. What StoryCode is a curriculum, a 1-year curriculum for high school. It could easily work in middle school, just have to adjust the texts. Okay, that uses literature to model computer programming principles, which you can because of this, because you're mixing fiction and STEM. It can be taught in almost any context, okay? ELA teachers who feel comfortable with technology and want to bring programming into their classroom, it works fine that way. STEM teachers who want to try to use fiction to get a new level of engagement or involvement or activity in their classes, works absolutely great for that. If you're a school leader who's trying to figure out how the heck am I going to get computer programming into, is this working? So here's an example of a lesson plan that introduces the concept of binary through the short story, The Lady or the Tiger. Okay, that's a kind of sexist 150-year-old short story about choosing between two doors. Okay, I've adapted that story. Sorry, what we got here? Adapted that story, and this is an important part of it. You take these texts, you don't have to use them verbatim. You are allowed, in the name of knowledge, to massage and adjust them. You don't want to change anything vital to the story. You shouldn't have chosen the story in that case. Okay, but I have a clear conscience about adapting Frank Stockton's language, and of course, photocopying it out in a scaffolded text where we can, instead of going at his Victorian prose as a big chunk, we divide it up. Okay, what does this paragraph mean? I'm going to put it here in my own words. This, of course, is a standard STEM problem-solving technique and computer programming practice. We take big problems, we break them down into smaller problems, and we solve those. All right, so getting back over here. Standards bingo, right? Okay, so here's the lesson plan over here that I follow, and so I have to take it upon myself. What standards does this fulfill? Well, this is just the beginning, okay? I had to stop myself from going too many levels deep and very quickly had to, turn my spreadsheet sideways and adapt a color-coded system, okay? The reading standards in red, the writing in purple, which doesn't come across so well here, math, content, and practices in blue, science, technology, green, and the CSTA practices, standards rather, in black. And you can see, except for a few things which slip through the cracks, it's hard to bring fiction and computer programming or any STEM material together without, lighting up all these CCSS active zones here. We serious about 5 minutes? Is that the 5 minutes? You got the hook?
Yeah, I think we've got everybody here for a long time. People are starting to trickle out. So if you would like to speak with any of our presenters in more depth, they'll stay up here for a few minutes, and I'm going to thank everybody at this point for coming out and for being here, for being so attentive, and for helping make this. So again, thank you so much for coming, and come and grab our speakers if you want to talk more in depth.